Thank you. Hi, everyone. My name's Spencer Gietzen. I'm with Rhino Security Labs, and I'm here today to talk to you about Pacu, which is an open source AWS post-exploitation framework. So start off with a little introduction. I'm a penetration tester. I focus on the cloud and Amazon Web Services in particular. So that's kind of what I do. I'm the lead developer of Pacu. We've got an internal team that works on it, and I was kind of the one who brought the idea up and worked on it solely for quite a while before we moved on to, bringing in some outside help and other team members. So I'm here to talk about AWS security and penetration testing, and how Pacu solves some problems in the industry that we have right now. AWS security in general. AWS in general, even it's easy to get started, but it's hard to master and get everything right. There's a lot of different resources that are good, really good help. There's a lot of white papers that AWS publishes, a lot of blogs and different research that the community posts, as well as just the general AWS documentation. It's all great places to learn, but it's hard to know if you're doing something 100% right and if you're doing everything 100% right, because it doesn't really matter. You could be doing 99% of what you're doing correct, and that 1% could be the end of your company, depending on a lot of different things. But so it's so hard that even the best mess it up, and that's been shown time and time again. A couple of examples are Uber. They had the GitHub repo misconfiguration where one of their developers or someone pushed some API keys, access keys, to their GitHub, where hackers were able to steal those, gain access to their environment through that way. Tesla is another one. They had a public-facing unsecured IT admin console, and a hacker is able to get into that and retrieve some keys they had stored there, which they then used to mine some cryptocurrency, which is a large theme in these kind of hacks, but it's really not. That is definitely a big threat, but it's not all there is when it comes to these kind of attacks. Accenture and many others, as I'm sure everyone is aware, S3 bucket misconfigurations. Publicly allowing access to private data, company data, employee data, payment info, tons of different things that seems like it's happening every other week that something comes out about a new one that's going on. But the real threat, so that is authenticated compromise. That's not just having someone find your S3 bucket that's facing the internet. It's when your keys get compromised. And that can happen in a variety of different ways, such as GitHub commits with Uber, social engineering or phishing to get your password or secret keys, password reuse. This is something I see a lot as a pen tester myself. I go online and find a public database dump with clear text passwords, associate it with someone's email, and then I go and try and log in on a different website with the same email and same password, and it logs me in. That's extremely common, more common than I would have ever thought. Then as well as web app vulnerabilities. So there's server-side request forgery. You can, contact the EC2 instance's metadata API to retrieve temporary AWS credentials for an IAM role that's attached to an instance. So with just server-side request forgery, you could gain as much AWS access as that server has. Or local file read. So through any method, RCE, LFI, any of that, you can discover keys that are stored locally on this system. As much of a bad practice as that may be, it's still something that's common, and people aren't, doing it correctly all the time, and that's what I found. As well as internal threats and rogue employees. You don't even need to worry about the compromise in that situation. They already have access to your environment. Are your permissions set up correctly so that they can't end you or cost you thousands of dollars? It's a lot of different things that can happen here. So penetration testing on AWS. There's a lot missing from the penetration testing industry in regards to the cloud and AWS, but there's a lot of configuration scanners out there. A lot of best practice checkers, configuration checkers, A couple of those, Scout 2, CloudSploit, Prowler. There's a lot of others. Those are all really great tools. But there's not much for an attacker. How do you go and capitalize on a misconfiguration? How do you exploit something, some certain setting? How do you gain access to the environment, escalate your privileges, all that different stuff? There's not much out there. There's a couple of them, AWS Pwn, Nimbo Stratus, or the weird AWS attack library, all great tools, but those and other AWS attack tools all kind of have a common theme. They're kind of forgotten about or stopped working on, where you see on the GitHub hasn't been touched in 2 years or 6 months. And that's not what the industry needs if we're going to advance the AWS pen testing industry, because AWS is constantly updating their APIs, adding new services, deprecating services and APIs. The tools need to stay up to date with what you're attacking, obviously. So it's also something that's hard to learn without practice. How are you supposed to get into AWS pen testing? I don't know, if you don't know much about AWS, you probably have no idea. And so you need to practice it. But how are you supposed to practice it without an environment? Some sort of lab environment. What you need basically is, as a pen tester, you shouldn't have to worry about deploying the different AWS resources that you want to pen test against to simulate a customer's environment, or worry about the misconfiguration of those resources to put some vulnerabilities in there and know that there's something you can exploit, and you shouldn't have to worry about a high cost as you're going through these things. You shouldn't be charged, I don't know, even $50 for testing, trying to learn pen testing on your own account, on your own accord. And if you're not familiar with AWS, it's hard to make something like that happen. So really, if only we had something like WebGoat for web applications, where you can host your own thing and go wild on it. And so with that, it kind of brings me to CloudGoat, which is a vulnerable by design AWS environment that we recently released at Rhino Security Labs. It's built to enable AWS security education. We made it so that you can learn and get into AWS pen testing easier. Make it so anybody can do it, rather than somebody who has access to some sort of environment or has enough knowledge to deploy those resources. Ultimately, it will help attackers and defenders in the sense that it'll help them understand different misconfigurations, what even just normal configurations can do to your environment if a certain user has a certain amount of access or something like that. So it's deployed and destroyed on demand with Terraform. You can just run the start script, launches all the resources into your account, logs the credentials, so you can choose a starting point, and then you can destroy it at any time. And it's easy to do. We integrated 9 commonly misconfigured AWS services with plans to expand on that. So that includes IAM, CloudTrail, GuardDuty, EC2, CodeBuild, Lambda, Lightsail, S3, and Glue. So there's a variety of different resources within those services that we've created. So there's multiple starting points. There's a few different IAM users, and there are a couple of different instances that you could start in. So it's kind of, you choose your path and your simulation of an attack. Did you steal someone's password and you have console access to someone's account? Did you hack a web server and you got access keys or something like that? Or did you get RCE on a server that doesn't have AWS, or like I guess RCE on a web application or something like that? So you are in the server, you're on the command line in the server, then that's where you're starting. A lot of different ways to do that. And with that creates a lot of different attack vectors. So there's currently 20 plus in the environment, different ways to escalate privileges, disrupting and evading logging and monitoring, data enumeration and exfiltration, persistence, and a lot of others. we try and incorporate as much as we can in there to give you a well-rounded idea of pen testing and misconfigurations in AWS. It's inexpensive, so this is another big worry that we encountered. Currently, if you just run the environment, it's about $1 to $3 a day based on how much you're using it. If you're attacking it for 24 hours straight, obviously it'll be a little bit more than that, but this is off of the free tier. So, it's really cheap, and based on the start script, or based on how it starts up and gets destroyed, you can deploy it and destroy it within just a couple of minutes. So even though it's cheap and everything, we always suggest you can start it when you're ready to start pen testing it, then you can tear it down when you're done, and you don't have to worry about any hidden expenses that way. It's relatively safe. It's safe in the idea that, obviously, everything's misconfigured, so that's not safe. But all ingress traffic to any instances in your AWS account are whitelisted to an IP range that you supply when you're starting the environment up. So this keeps access to those misconfigured resources to people on your IP address, or people who have access to the credentials that you just created, which ideally is just you. If it's not, then you probably have other problems. Even given that, it's not recommended to launch alongside other resources, though, in your account, as obviously they're misconfigured, and if they're in the same account, they can have access to certain things. So, we'd never suggest deploying it next to your production environment or anything like that. We already released it on GitHub a week or two ago with the BSD3 license, so that's it's ready to get started with and start learning. I've got a video here that maybe not. There we go. All right, so basically right here I'm starting the start script. I passed in localhost as my IP address, or my IP range. So it's going to whitelist everything to that IP, and only people with that IP can access the server. So then you can, so then it'll run. I've sped the video up quite a bit because it takes a couple of minutes, but so now Terraform's going through and creating all the resources in your account. It's doing everything for you. You can just wait for this to be finished, and then it'll be ready to go. So takes not too long. Just I think 2.5 minutes was what this, before I sped it up, ended up being. I don't think that's too long. Just waiting on the finished. So finishes. You see the Terraform message. It's added 38 resources to your AWS account. And then the GPG message there is decrypting a couple of the passwords for the user accounts. And it just outputted that into a credentials file where you can cat that. And these are three of the different starting points for the CloudGoat environment. Feel free to try those credentials if you want. They won't work. In this talk, in general, they'll work. So, you could start as the administrator. You just access the administrator's account. Bob, Joe, they all have different permissions, different, sets of access. So that means there's different attack vectors from each account, and you can learn a variety of things that way. And then to shut it down, it's just the kill script, and it uses Terraform to take down everything in the environment as we can see here. And that is it. If you don't know Terraform, that only kills those 38 resources we add, nothing that exists in the environment, although you shouldn't be running it against an environment with resources already going, but separate. So we have a vulnerable environment now, and we're still missing something. That there's more to pen testing and security than just this, just a vulnerable environment. It's hard to, how do you know what to do? How do you automate these things? How do you manage these attacks? And really what's needed is a tool that can turn complex multi-step attacks into just a couple of commands. And removes a lot of the work on your side of things to, just to what that tool is doing. So you don't have to rewrite a bunch of code every time you want to do this certain attack. You don't have to go find it in your operating system. You don't have to integrate someone else's code to try and fix some weird bug. It should just be able to handle those things. It needs to be future-proof. So that means it needs to be modular to allow scripts to work together. You write an enumeration script, it enumerates some data. When you're later writing an exploitation script, whatever that may be, you don't want to rewrite the enumeration part. So you should just be able to assume that data is there and something will get it for you. And it needs to be extensible because AWS is constantly growing. So the tool needs to be able to constantly grow and shouldn't require framework updates every time there's a new AWS update or something like that. And really, configuration scanning is great and very helpful and something that is definitely needed, but we need something to exploit those misconfigurations and capitalize on them as attackers. There's basically those scanners are the Nessus of the cloud tools, but we need the Metasploit. So the solution to this, Pacu, the offensive AWS exploitation framework. It's written fully in Python 3. It covers the attack chain, or the kill chain, so it covers reconnaissance, logging and monitoring, persistence, privilege escalation, data exfiltration, and just general exploitation. So the module's simple to develop. We've got a built-in template. All the modules are structurally separated, so all you have to do is add a folder, copy the template in, and your module is in Pacu. And then obviously you got to write some code, but we try to make that as easy as possible. So like I said before, you shouldn't have to worry about enumerating data if that's not the point of your module. You should just be able to say, I need this data, and then the Pacu framework figures that out for you, and it gives it to your module. So you can, that's a lot of code that you don't have to even think about. You can, in general, that makes it a lot easier as, it takes a lot of worry and even syntax down to, you have less lines of code. You don't have to worry about errors coming up. So it's extensible. We've got a built-in API that we expose from the Pacu core framework to module developers to make things easier. I'll get into that a little bit more later on, but in general, it takes out annoying and repetitive code out of your hands and gives you simple one-liners for those. There's session data management, so it handles sessions in a variety of ways, but basically you can create a session for a company that you're working on, and it keeps all the data and keys and anything that's gone on, logs, everything separate from another company that you might be working on, another client. And that ties into data management through SQLite, which is we use a local SQLite database to manage all the data that gets enumerated as you're attacking these environments and everything that you need saved. And there's global error handling, so Pacu's not going to crash and corrupt your database. It'll always work. It'll always catch those things, and you don't need to worry about that kind of stuff. And just like CloudGoat, Pacu is open sourced on GitHub as of an hour ago or something. So that's exciting. It's on the same. Whoops. Oops, sorry about that. Okay, so it's on GitHub. So Pacu and CloudGoat were built with each other in mind, and many of the vulnerabilities in CloudGoat were tied in closely with exploits and modules that are in Pacu, and the plan is to grow them together as well. So as Pacu modules are built, that means we'll integrate those vulnerabilities and techniques into CloudGoat, so you can capitalize on those and test those modules, and then the reverse as well. It's a really great way to learn Pacu, learn pen testing, and in general just get an idea of what's going on before you go and test this against a production environment or something like that. So I'm going to go through a Pacu demo now. Basically, this is a post-compromise scenario. So I've compromised someone's keys through some method, and that's all I know. I don't know anything else. I just have those keys. I'll go through, using the Pacu console, enumerating permissions, settings, different data, escalating my privileges to an administrator level, establishing persistence in the account, backdooring security groups to gain access to certain services, and then compromising EC2 instances through remote code execution. So, oh my God. Well, it seems to be frozen. Well, all right, I guess I'll go with the video. I have a video of this. Not sure why that's not working, but okay, so what we'll go through here is first running Pacu. Splash screen comes up. We get the Pacu ASCII logo, and underneath here, okay, so you can see there's at found existing sessions. I already created a session for BSides, but if there was no session, tell you need to create one. You have to give it a name, and that'll encompass your project. So, accept that. I'll choose, put in one, accept my thing. So then it'll come up here. We have a lot of different help information, a lot of different stuff pops up here, not so important quite yet. Down in the bottom left, you can see BSides Las Vegas, Spencer. So in this case, BSides Las Vegas is your active session. So you always know when your session, you always know what company you're working on. You don't have to worry about accidentally attacking a different company or anything like that. And then Spencer is the pair of keys that I compromised. I set the name Spencer to them because I don't know anything about them, and my name's Spencer. So it can be anything you want. So it makes it easy to know what you're doing. There's a lot of different help here. So basically, some of this different help stuff, there's the ls command that was just run that lists all the different modules that exist. You can see the category they belong to as well. There's the search command that you can search for a string. It gives you the name of the module as well as a quick one-liner of description for that module. There's also, this can help you get a better idea of what you're trying to execute and what you want it to do. So to do this, in this case, there's also the set regions command. This is a pretty important one that we built in. So in this case, I just set the regions to US West 2. And what this does is it ensures that any module that uses regions in one way or another, there's global AWS services, but a lot of them use regions. This will ensure that a module will not be run against a service that doesn't support a certain region or isn't supported in a certain region, as well as it won't run against regions you don't want to target. So I run a module, it's going to check what service or what regions are supported for that service. Then it's going to check the session regions, and it will only execute against regions that are in both lists. So you always know exactly what you're targeting. You don't have to worry about any of that. Okay, so then there's the who am I command. This will give you a lot of different information here. Currently, there's not any information because all I've done is set these keys. I haven't done anything else. But a lot of different stuff, including the keys, and then the key alias, just what I named them. And then to gather the information that goes in those different places, you can run there's modules that will contribute to that over time. And so what's going on here is there's tab completion for every command, every module. So you can tab complete any command and the modules that you're trying to run. I'm using the run command here to run the confirm permissions module. And then there's also argument auto-completion, but in this case, I'm not using any arguments. So I'm going to run confirm permissions. That's going to run, OK. So now we've got module summary that pops up. Confirm permissions has completed, and it says it's found confirmed permissions for demo. What that means is it confirmed permissions for the username demo, and that tells me the keys that I named Spencer are actually named demo. And that's something I could change later on, but it's not all that important right now. So now if I run the whoami command, we'll see a lot more data that's populated. So now we can see username, user ARN, account ID, user ID, roles, groups, policies that are attached to your user, the keys again, alias, and then permissions confirmed. That's a pretty important one. Currently there's only one module that sets that setting, and it's the confirm permissions module. But what it means is that when these permissions were enumerated, it was 100% sure that that is the full list. And it's not just through testing it discovered this. It knows that this is the case. And so we can see I've got some IAM permissions, Lambda, and RDS. I'm not explicitly denied any permissions there. So yeah, we don't need to worry about that. Me?
We're getting a lot of background noise.
From the video? Yeah, there's no sound there. Well, as long as everyone knows it's not my video. So what I'm doing here is we saw that there were, IAM, Lambda, RDS permissions. I'm going to run the enum EC2 module against instances and security groups. We know this won't work, but it's just to show you, give you an example. Use the dry run feature of the AWS Python library, Boto 3, and it's confirming whether this account has those permissions or not before trying to actually execute the commands, which I don't. And so then it's telling me nothing to enumerate. That's it. You can't do it right now. You don't have permissions. So what that means to me is that I need to escalate my privileges so that I can run this module. And to do that, a lot of different modules, obviously they're complicated. So there's a help command that can be run. I'm going to run it on the privesc scan module, which not so important right now, but basically it just gives you the arguments that you're allowed to use, as well as a long description of what it's going to try and do. But right now, all I'm going to do is just run it with no arguments, and we'll see what happens. Okay, so what happened here is it confirmed. It found one privilege escalation method that my account's vulnerable to, and that's the create new policy version method. These are all things that I wrote a blog about in the past, 21 different privilege escalation methods that it checks for, and then attempts to exploit to gain privileges for you. So it's going to start doing that. It's going to ask if there's a policy that I want to target for this method, but no, I'd rather it just finds it for me, finds a valid one. So I can just hit enter, and it will shortly do something. Maybe. So now it's found, it went through and found a policy that was attached to my user, confirmed that it was a user or customer managed policy rather than AWS managed policy, which means we can create a new policy version for it. And if you have permissions to create a new version for a policy attached to your user, you can create any policy and give yourself any amount of privileges. So now it's going to say I have administrator privileges, which are star permissions on star resources, which is just the wildcard character. So now I can go back through and run the confirm permissions module again to confirm with myself that yes, that worked and my account has this access. So run that, pops up, same results as before, and then I can run who am I, and now we can see I have all the other permissions are gone, and I have star permissions on star resources, aka administrator privileges. So now I can go back and run that EC2 module that I wanted to run by just another confirmation that this actually is happening and actually working. So I can run the module, enumerate instances and security groups. I found 3 instances and I found 1 security group. And because I set my session regions to US West 2, that's the only region it targets. Otherwise, by default, it targets all valid EC2 regions. So that's going to finish there. So now I've got administrator privileges. I'm going to want to establish backdoor persistent access to this account in one way or another outside of just this current user. So I'm going to use the backdoor users keys module, which will attempt to add a set of access keys to a different user in the account. And I didn't pass any arguments in, so it's going to ask if it wants to ask if I want it to enumerate those users and then prompt for each user rather than just spraying across the whole account and making a whole bunch of noise. So I'm going to say yes to that, and now this message is saying it just checked the database for a list of users, and it wasn't there. Now it's going to, but it knows where to get it. So it's going to ask, do you want to run this other module to enumerate a list of users that we can then use here? And I'm going to say yes to that, and it'll run the enum users, roles, policies, groups module, and it's going to enumerate 11 different users. So now I can go through and say which users I want to add some keys to. IT admin, that sounds like a high privileged, strong account, good backdoor access. So I'm going to accept that and get some backdoor keys there. And once again, I know where I am, so those are not valid. Don't try and use them in the audience right now. So now I've got those ready. Now I'm going to say no to the rest of them, keep moving, and I can now use the set keys command that I had used prior to the presentation, but now you can actually see it in action. Set keys, it's going to ask for a key alias, which is previously Spencer. I'm going to name it IT admin. It's going to ask for my access key ID. Just copied that from above, and that's going to ask for my secret access key. Paste that in there. And so now I've got 2 users stored in the BSidesLV session, and I can run who am I to confirm that they're different users, they're separated, and I can use the swap keys command now to switch back to my administrator, because with backdoor access, I want to leave that there, hopefully keep it as silent as possible. In the meantime, I'll use my administrator privileges to expand in the environment. So do that, run who am I again, just to show they are separated, still back to the regular Spencer user. And so from here, we enumerated some data throughout so far, and I can use the services command, and it's going to list the AWS services that have data collected for them stored in the database. We've got EC2 instances, security groups, and we've got IAM users and roles. I can then use the data command on one of those services or all of them, whatever you want to do, but I'm going to run data on EC2, and what's going to happen here is you can see whoops. So I'll run that, and then it's going to pop up, and you can see there, right here is the some rules for the security group. We know there's one security group, so we know all the EC2 instances have a single security group on them, attached to them. We can see there's port 27017 whitelisted to some IP for inbound access, and it's got the description Mongo. So my assumption would be there's a Mongo database running on that port for the servers. And so what I'm going to do with that is I can confirm that, well, for one, I don't currently have access. We know that, but I can confirm that, I can test it out, and it'll fail to connect. And that's what I'll do here shortly. So just some IP, this is some company's IP that they whitelist access, and they don't want it public facing, and they don't want it facing other things. So exit out of Pacu, I'll use the Mongo shell command to connect to the host that's running the Mongo database instance, and pass the IP in right there. And as we can expect, it's going to sit there for a sec, and then it's going to fail to connect. And obviously we knew that. Now we're going to go back, and we're going to give ourselves access to this port so that we can get access to the Mongo database. This can be done with the backdoor EC2 security groups module. I'm going to pass in an IP range, which is the IP for the server that I'm running this on right now, as well as the /32, so it's just that IP. And then I'm going to pass in a port range for 27017 to 27017, since that's the only port I care about right now. I could do 1 to 65, 65,000 or whatever, the max. And then I'm going to pass in the security group I want to target. By default, it's going to target all security groups, but just as an example, I'm using this here. So I'll pass in default at US West 2. So you can pass in a bunch of different regions. And in this case, if I passed in a security group in a different region, it would still target it because I explicitly told it to, regardless of what my session regions are. It allows you to override it in cases that you would want to, but it won't ever override it in other cases. So we'll run that, and we can see it targeted the group default. It applied the security group rule, success. Port range is open for my IP. All right, now I should be able to exit out of Pacu again and use the MongoDB shell to connect successfully and access the database, and hope that they didn't set up, authentication or something like that, as has been relatively common with MongoDB in the past. So I'll exit out of this and run that command again. And so now we're connected. You can see I've connected to the Mongo database. There was no authentication, so now I've got access. And all it needed was just a security group rule change. And it's that easy. You can just use a module, basically. So got access. All right, I'm going to go back to Pacu now. And I'm going to try and get code execution on a EC2 instance that exists in the account. There's a module built for this that's called the, so first I'm going to set up a listener with netcat. It's going to listen on port 5050, listen for a reverse connection, which is what I'm going to send to these EC2 servers, and hopefully get something. And this is done through the sysman EC2 RCE module. And what that is it uses Simple Systems Manager to try and execute commands on instances that have the Systems Manager agent installed on them by default. There's a couple of different commands or arguments you can pass in, but by default, it's going to scan all the EC2 instances AMIs and then try and detect if that operating system has the Systems Manager agent installed by default or not. And if it is installed by default, then it'll add it to the list of targets. You can just spray it if you want against everything in hopes that someone installed the agent, but by default, it doesn't do that. So I'm going to pass in my command that I want to run on those instances. which is just a bash reverse shell, and it's hopefully going to connect back to my server. So I'll pass in my IP and then the port 5050. Okay, so we'll run that, and then it's going to scan the EC2 instances, AMIs. We can see it found one vulnerable image. Doesn't matter necessarily how many instances there are, but it found one of them that has a vulnerable image that is installed by default, the systems manager agent. So it's going to run that. Then it needs the systems manager role. And we haven't enumerated roles yet, because earlier we only enumerated users and then roles, or policies. And that's all through arguments that you can pass to those modules. So a lot of different stuff has happened here. What basically it runs the enum users roles policies groups module. It found 24 different roles. It's then going to search through there and see if there's an existing systems manager service role, which there is. It found it. It's called SSM. And then it's going to check if that role is associated with an EC2 instance profile, and it found that as well. It's called SSM. If neither of those existed, or if one of those existed, it would create them and associate them. So regardless if they exist or not, ideally it'll get created if you have the correct permissions. So then it's going to attach those to the targeted EC2 instances. So the instance ID, 0A, whatever, that was the vulnerable instance. It attaches that systems manager profile to it. And by default, it's not going to replace any roles that are already attached to instances to prevent a denial of service through some method or another. But there's arguments to do that if you'd rather, go all for it and try and get access regardless of what happens to their instances. So after that's attached, it can take up to 10 minutes or so before the systems manager picks it up as a target. In this case, it was instant, so it detects the instance, runs the command on it, and we can go back to the reverse shell when this is finished, and we'll be able to see that there was a reverse shell created. And systems manager runs as root on Linux instances and runs as system on Windows instances, so you get high-level access to those EC2 instances that it works on. And we'll see that shortly. Okay, so now we can see that we've got a connection on port 5050 from this IP, and it opens up the shell. I've got a root shell. I can run who am I? I'm root, obviously, you can see that already. And then you can run the hostname command after that, and just to show that, yeah, it's a EC2 instance, and we've got access to it. And at this point, there's quite a bit you could do to expand access from there, but a lot of different things to work on there. So that kind of wraps up the demo there. Let's see. Okay, so I'm going to talk a little bit about development now. Writing modules and how you go about doing that for Pacu. We've got the template that I talked about earlier. Makes things easy, makes it simple to go ahead and start developing. And then the built-in API that I talked about, I'll get into some of the actual functions here. So the get regions command, I've already talked about that with pretty much making sure you only target instances you want and valid instances for those regions. There's also an update regions command. So new region gets released for a service, you can put it into Pacu just by running update regions. And whenever me or the team pushes a change to the GitHub repo, we always run that first to ensure that the latest version that you clone is the latest version of the regions. Then there's the get boto3 client and get boto3 session calls, which those are the boto3 library is the AWS Python library, and creating a client and session is how you interact with the AWS API. So we wrapped those into these functions to reduce a lot of repetitive code that you might have to write, like the current keys, the current set of keys that you want to create that client for, or different things like that. And we also added a little bit of extra functionality to it. There's some stuff that goes on in the core Pacu framework, such as like user agent modification, which can be used to bypass some guard duty. There's a guard duty rule that can be bypassed by that, and so what that does, it flags on a user making AWS API calls from Kali Linux, and you can change your user agent so that it doesn't detect it's Kali Linux, and then you bypass that. You don't have to worry about that. There's the key info function. It gets all the relevant information about the account, which is basically the who am I command. Allows you to work with that programmatically. And then there's print and input, which are overwrites of the built-in Python print and input, and it allows it so that you can write directly to a log file as well as the screen by default. And that allows you, there's also, we added some more options in here as well. So you can choose, maybe this data only needs to be written to the log file, or maybe it only needs to be shown on the screen, or both. There's a couple other small settings you can change on there as well. Then there's a lot of functions to work with the SQLite database, make it easy for you to read, update, manipulate whatever data in the database, and make sure everything's working fine. As well as the wiki on our GitHub, we've got some developer documentation and different resources that you can go to learn more about Pacu and building for Pacu in general. So really, we've talked about the problem with AWS security right now, and it's that there's a lack of attack tools for us pen testers, and there's a lack of security training and practice labs for those kinds of attacks. And so it's hard to get into it if you're not already in the AWS space. But we fixed those kind of things. That's the goal with CloudGoat and Pacu. CloudGoat being the target environment, allowing you to practice your methods, and then Pacu allowing you to manage and automate a lot of the attack process. And so I've included a couple of resources here for anyone interested in the different privilege escalation methods of the privilege escalation exploiter module. Those are all documented there with how you exploit them, the methods, and then the ideas behind them. And then there's the Pacu GitHub repo at rhinosecurity-labs/Pacu, and the CloudGoat repo at rhinosecurity-labs/CloudGoat. I've also got my email there, my Twitter, which is at SpenGeets, and then the Rhino Twitter at Rhino Security, and I'll be posting these slides on GitHub tonight. So if you're interested in checking these out, you can see all of that. And that kind of wraps everything up. So I'm really excited to get these tools released, and put a lot of work into these. It's fun to see people use them, and I hope it's as helpful as it has been to myself. So thank you for coming, and thank you for listening.
We do have a few minutes here to do some questions, if anyone has any questions.
Thanks for the talk. Looks like two really good tools, and I think it's needed as well. I have two questions. One of them a bit of party pooper maybe, and one probably more interesting. But as I recall, when I've done pen tests in AWS, they're quite picky about what you can test. So I think it was last time I checked EC2, Route 53, and the hosted database service. So, have you dug into this, and have you had any conversations with Amazon?
Yeah, obviously I'm not a lawyer, but we built CloudGoat in a way that, in our interpretation of the AWS acceptable use policy, does not require you to break it to pen test the environment. So you don't need to. I'm not a lawyer, so this is, but you don't necessarily need to, by my interpretation, fill out the AWS pen test form, because all the misconfigurations in the environment are acceptable under the acceptable use policy. And Pacu is a different story that, depending on which modules you're using and everything, you may need to fill out the pen test form, but that's if you're using it against a target environment that you don't have permission to, which you shouldn't be doing at all. So in most cases, it does work out with that. Does that kind of answer your question?
Yeah, sure. And the second question, the interactive CLI, did you do that customly, or did you use like CMD2 models or something for Python?
It's custom built. It's pretty much just a while loop that checks the commands of the input that's getting sent in.
Hey, thanks for the great talk. With the account access stuff, it's a common pattern in AWS to have one account that users log into and then they assume role into separate ones. Mm-hmm. Have you looked at SDS tokens for persistence or assume role activity with your auth modules at all? Yeah, so the credential database, you can use temporary credentials as keys to attack, and there's a couple of different ways that persistence is something we're still working on in terms of modules, but there's you can backdoor the assume role policy of a role. So you can get permission to assume roles, then you can backdoor those to give your account access, so that at a later time you can request some temporary credentials for those.
Time for one more question. Okay, big round of applause. Thank you very much.